Hello everyone, welcome back. Feeling lost about AI agents? Honestly, you're not alone. The whole internet is noisy and contradictory. In this video, I'm sharing my mental model, the way I actually been building AI agents for last 18 months. No buzzwords, no glossary dump. Think of this video as a goldmine, a clear, practical way to reason about agents that you can use in your own projects. By the end, you'll understand how I approach them, and you will have a simple lens to evaluate, design, and ship with confidence. Let's get started. So an agent is a software that repeatedly plans, acts with tools, and updates its understanding until the goal is met. So it's not a single LLM response. It's a loop around an LLM. As you can see here, there is a goal and LLM is making a decision what to do next and calls the tool. Tool will respond with certain data and LLM will update its context and then call the tool again, depends upon the response. I know, kind of confusing. Let's unpack this. So when user asks the agent about something, the LLM will analyze the user input and see if it needs a tool call. If it needs a tool call, it will call the tool. If the tool call is sensitive, for example, if it needs to write the information to database, or if it needs to read some kind of sensitive information, it will ask the user, hey, can I use the tool? Once the user confirmed, the user confirmation is optional here. Once the user confirms, the tool will execute and it will respond to the LLM. The LLM will read the response with the updated output from the tool and it decides whether it needs the next tool call or not. So depends upon that response, it will send the output to the user. So basically that's exactly what's happening here. So there are three main components in the agent. The first one is the goal. The goal is the natural language description of the job of the agent. For example, let's say the goal of the agent will be your travel agent, your responsibility is to search for the flights and book the flights. And then the second one is the tool library. Each agent will have certain tools in the tool library and each and every tool have a description. The description about what tool does, what it takes as input, and how it will respond, basically the output of the tool. Since our agent is the travel agent, we have two tools. One is the flight search tool, other one is the flight booking tool. So we'll take the information from the user about where he is traveling and when he is traveling, and then sets the flights accordingly. The flight booking tool will take all the information from the flight search tool, gets the user response, and then will book the flight. So the basic point here is the language of the goal must be aligned with the language used in the tool description. So LLMs, of course, able to figure out the general concept around what this tool does. So the exact wording is not necessary. But the greater the alignment, the greater the chances the LLM will steer correct. So yeah, three things. The goal of the agent should be very clear. Number two is that in the tool library, each and every tool should have a clear description about what it does. And number three is the alignment between the goal and the tool description should be clear. All right, let's move on. LLMs are pure functions. Basically, the better tokens you're sending in, the better tokens you're getting out. Fun part, you can also use agent as a tool to the another agent. For example, let's just say instead of using flight search tool, flight booking tool as individual tools, you can create another agent which can do the job, right? You know the single responsibility principle in software engineering? It's applicable for agents as well. So the lesser the responsibility of the agent, the better it will perform. So it's always good idea to implement agents around that single responsibility principle. So far, we looked at agents from the builder perspective, right? Now let's look at from the application point of view. For example, ChatGPT or any other application which uses LLMs and tools. So this simple flow diagram will explain how these things work within the application. So in the first step, what happens is agent will assemble with the initial context window, and initial context window will have goal, tool library, tool descriptions, or any other initial context that user provides. So in the next step, it will invoke the LLM and check if the goal is achieved. If the goal is achieved, it will exit the loop and return the result. Otherwise, it will prepare for the tool execution. It will look at the specific tool library and calls the specific tool which needed for the specific goal. Then it will invoke the tool and update the context window with the results. In the next turn, it will run the LLM with the updated context window and run the same loop until the goal is achieved. So that's mostly what's happening when you're communicating with these chatbots like ChatGPT or any other applications which are using LLMs and tools. So far, we have seen how single agent talks with tools. Now let's zoom out and let's talk about how these agents work together. In other words, let's talk about agent architectures. We'll talk about sequential handoff, a supervisor with helpers, and teams running in parallels. Let's jump in. We have seen single agents, right? Single LLM with a loop. But what if we want to perform a complex task? Remember the single responsibility principle? Each agent should be responsible for doing only one thing. If we want to perform a complex task, we need individual agents which are good at doing that specific task. For example, let's just say we want to build an agent which writes the poem and then evaluate itself. So in this case, our first agent will write the poem and second agent will take the response from the first agent and evaluate how it is, right? Agent 2 only executes when agent 1 stops executing. So they won't execute at the same time. Basically, agent 2's context comes from agent 1. Now let's move on to the hierarchical agent. This is where the fun begins, right? So far we have seen sequential agent. So sequential agent only performs one task at a time and they are sequential, right? So there are no manager agents or anything. What's happening here is we have a manager agent. So it takes the input from the user, decomposes the goal, and then split the goal into individual tasks and delegate the task to the appropriate agents. Let's just say we are building the data analysis agent, right? So for this scenario, there are 3 individual agents. They are pretty good at doing one specific thing. So research agent is good at doing research, writing agent is good at writing, and then data agent is analyzing the data and storing the data. So manager agent knows which agent is good at what. That's why the goal should be very clear for each and every individual agent. So manager agent takes the task, delegate the task to appropriate, analyze the output, and send the output to the user if the output is good. Otherwise, it'll send back to the agents again. Now let's move on to the parallel agents. So parallel agent is also a hierarchical agent, but instead of executing tasks sequentially, it delegates the task to multiple agents at the same time, and these agents work independently to finish the job. So manager agent takes the output from these individual agents, analyzes it, and if the output is good, it sends back to the user. But the big advantage of this is the speed, right? Here you're not executing one agent at a time. So in each and every individual agent performing independently. For example, I'm pretty sure you guys have already used deep research agents, right? They're available in all the platforms like ChatGPT, Gemini, Claude, and all that. Basically, what's happening there is a manager agent or orchestrator agent which takes the input from the user. For example, user wants to buy a washing machine and then ask an agent to research about washing machines, right? So manager agent figured out and then delegate the task to these individual agents. So individual agents could be like agent 1 is responsible for searching the internet, agent 2 is responsible for searching YouTube, agent 3 is responsible for searching the Reddit, agent 4 is responsible for searching Instagram or something like that, right? So they perform their individual tasks and do the research and send back to the manager agent. So manager agent will evaluate, check the results and send the output to the user. So that's an example of parallel agent. Now we will talk about when to use parallel agents and sequential agents. So if you see here, there is no context sharing between these individual worker agents, right? So they perform independently. They don't have any idea what other agent is doing. This specific architecture is good when your task doesn't need the context sharing between these individual agents. For example, in our previous example, we are evaluating the poem, right? So that means second agent needs the poem to evaluate. So there is a big context dependency there. So it needs to share the context between the agents. But here, in the deep research example, it doesn't need the context. So it can work independently to do the deep research. Awesome. So that is my mental model of AI agents. So now you have a solid understanding of what AI agents are, when to use them, and some great orchestration patterns that you can start with. So now you need 2 more things to build more efficient AI agents: memory and context. Memory helps these agents remember right things at the right time. Context is all about clear goals, clear tool descriptions, and small, efficient summaries. So only what's relevant flows between the AI agents. Remember in our parallel agent pattern where individual agents work on their own and then share the output with the supervisor agent? So that context sharing between the agents will unlock entire new use cases. So in the next video, I'm planning to show simple memory patterns, practical context steps, and how frameworks like LangGraph, LangChain, crewAI, and OpenAI Agents SDK fits in this agent ecosystem. If that sounds useful, stick around. This is the solid foundation, but we are just getting started. Thank you for watching this far. I'll see you in next one.